Hi all. Hi Rohit. How are you?
Hello. Yeah, I'm fine. How are you?
Yeah, I'm doing good as well. Thank you. Give me 2 minutes.
Yeah, sure, sure.
What did we do last time? I believe it was nice base. Did we complete this? No, right? Let me see. No, yes. So we have only looked into the theory. Okay. We have not looked into the practicals. Okay, no problem. Give me 1 minute. Let me just share my screen. Mm, yeah, I found the code. Very good. I have it full. Um, okay, let's give the folder first. Open a new window. Mm, Um, uh, and- okay, so this is here and then here, right? This is the first session, right, in the new year, I believe.
Yes, yes.
Yeah. Okay. Give me 1 minute. I don't think I have uploaded the video of the last class, which is okay. I will do that later on. After this session is over, I will do. Let me just share the files and share the screen. Today is what, 6th Jan, right? 6th Jan 2021. Done. Okay. Now let's come over here. Mm, 122. And let me share screen. Plus 122. Yeah. I hope you can see it now, Rohit.
Yeah.
Yeah. Okay. So just a quick recap. What we were doing was we were looking into knife base, and knife base is one of the probability models. Now, usually, knife base is really very fast. I'll talk about the good things and the bad things in some time. Let's do some coding, and then I'll talk about it. But what I have seen is that, or how it works is that only the step number one is where it is going to read and understand the data. So this is what is happening in case of the training phase. Everything else which we have is actually happening in the testing phase, right? Which means this algorithm is a lazy learner. Okay, this algorithm is a lazy learner. Which means it is not really learning at the first place. It's simply understanding the classes, right? Uh, and then it is going to do the execution in a certain way. So we looked into this. We draw a diagram and we said that we have a binary class classification problem, class one, class two. Let's say these are the distributions, right? So this is the probability of being in class one and probability of being in class two. Now around the query point, whatever is my unknown point or my new point, the algorithm will draw a virtual circle with k number of points. Now, since we are going to use sklearn, I just wanted to inform you about this. If I write my own algorithm into Python, then most probably I'll be able to do it. But if I do this using sklearn, which is what we are going to do, we will not be able to decide how many points will be there in that virtual circle. What I mean by that is, let's say these are my points of one class. Let's say for simplicity, I just have two classes, right? And here I have this new point, right? So let's say sklearn is drawing a virtual circle, which is something like this, right? Now, clearly we can see there are 4 points inside this, and obviously, if I consider this as the center of the circle, right, then obviously there is a radius to this circle also. I mean, if I want to look into it from a geometry point of view, which means, right, which clearly means that there is a dimension to this circle, to this virtual circle. Now, in sklearn, okay, we have no way to tune the virtual circle. We cannot decide how many number of points will be there, what is going to be the area of the circle, and so on. The basis its own implementation of the algorithm, right, which we may be able to find out from the documentation or from Git, right? That's how it creates the area, right? But nevertheless, it creates an area which has enough randomness, right? So we can trust it in that sense that it creates an area which has enough randomness, right? It's just not going to favor, okay? It's not going to favor one side of the things. But we have to take into consideration naive Bayes does not work when it comes to multicollinearity. If there is interrelationships between features, it will not work. If you have outliers in the data, it will not work. It will not work so well, right? It will not work so well as expected, right? Once the circle is drawn, it's going to see the number of similar and dissimilar observations within it, and P of X will be calculated, right? Basis which P of X given class 1 will be calculated. And then basis which finally we will use the naive Bayes formula to calculate conditional probability to understand given X, what is the probability it is part of class 1, right? So we calculated that in the last class as 0.31, and we got hence, because this is 0.31, this is the opposite is going to be 0.69, right? So in the same way, it will also work because this is working with respect to some kind of a voting. As you can understand, within the circle, there is a voting going on. So this will work for multi-class classification problems also. So it doesn't matter whether it is a binary class, whether it is a multi-class problem. Okay, naive Bayes works. And the reason why it is fast is because all we are doing over here is this multiplication and the division, right? So no more mathematical calculations are being done. We are not doing any logarithm, we are not doing any square or cube, something like this, right? So there is no calculation which is happening, right? So that's the reason with this algorithm, even if it does not do anything in the training stage and does everything in the testing stage, it is still fast, right? So that is the advantage of using naive Bayes, right? So I hope until this point in time there are no doubts. Let's try to continue from here. So what I would like to tell you additionally uh, is that the generalization for multi-class is also very similar. The only thing which is going to happen in case of the generalization for multi-class is that uh, it's just going to take into account the voting cases and the probability cases for all the classes. Here we had only two classes. There we have to calculate for all of them, right? Now there is one thing for which I have already written some notes. Let me just copy and paste this so that it saves our time. So let me just do a copy paste. I'm just going to convert this and change this over, right? So there is a concept known as Gaussian knife Bayes, and the reason why it's called Gaussian knife Bayes is because we will have part of our data cases where we have continuous data, right? Or we may have data that we want to treat as a continuous data. Now, when I'm talking about, let's say, uh, data which is really continuous into nature, the typical assumption is that the continuous values are associated with each class and that the continuous values which are associated with each class are distributed according to a Gaussian distribution. This is what we assume, because if we don't assume that, then our primary or our basic idea of statistics fails, right? The reason why we are able to accept or reject a null hypothesis is only because of the fact that we have a normal distribution and we are able to apply the empirical rule, and we are able to apply the concepts that we have learned in case of the hypothesis testing world, right? We are able to do that. Why? Because we have assumed or we have prepared our data so that we can convert it into a Gaussian distribution. Now this is quite easy when it comes to Python, right? We already know we have the library. In sklearn we have the pre-processing, let's say, module from where right? We will simply import the class which is standard scalar. We will create an object, and then we are going to do the changes in the data, which converts it into a Gaussian normal distribution, right? But when we are doing it, this formula that I have written over here, right? This formula that I have written over here is what takes into account. So I'll just read through the formula, or I'll just go through the formula so that we are able to understand what is happening in the backend. So I'm going to suppose that the training data contains a continuous attribute x. So x is actually the continuous variable which we have, right? So this feature which we have over here is a continuous variable, right? Now we have to first segment the entire data by the class, okay? And then compute the mean and the variance of x in each class. For example, I have three classes. Let's say this is a multi-class classification problem. I have C1, C2, C3, three classes. So I divide this range of x variable for each and every class, and then I have to calculate the mean, right? The mean, which is given by mu, right? This is mu. I believe because this is so small, we are not able to see it, right? And then we have the standard deviation or the variance, right? So sigma square, hence it is known as the variance. Now let mu c be the mean of the values in x with class C, and let sigma square c be the variance of the values of x associated with class. If I assume this, then the probability distribution, okay, of any given class x having a value v, let's try to see if it is part of that class C, can be computed by plugging v into the equation of the Gaussian distribution itself. So this equation is nothing which is specific to Gaussian naive Bayes, or it is not something specific to the naive Bayes algorithm itself. Naive Bayes algorithm is simply using this idea, right? Naive Bayes algorithm is simply using this idea, and this is what we are going to implement also. Okay, because generally what will happen is in our data, we will have features f1, f2 until f of n, where there will be many features which will be continuous features. There will be categorical features also, but we are going to convert them into numerical values only, right? So because we are going to convert them into numerical values, Gaussian naive Bayes is that implementation which is very easy, which is very generic, right? It is kind of an implementation which will work with most of the use cases. But that is not to say, okay, that is not to say that it is the only way in which in sklearn you can do naive Bayes. If you click on the documentation which is there, if you click on the documentation, you will clearly understand that this is not the only way in which you can implement this. There are other ways of doing naive Bayes also, right? So I've simply taken the formula from this sklearn website. Clearly, you can see it here, right? So this is where I have actually copied it. I have simply written it in a way so that it gets embedded into the Jupyter notebook here, using those text like this, right? So we can use text like this, and we can do that. So now, other than Gaussian naive Bayes, we have other things also. That's a multinomial naive Bayes, right? We have other components also. Let's say multinomial naive Bayes, complement naive Bayes, Bernoulli naive Bayes, categorical naive Bayes. Now they have their own use cases, right? But what we have seen in the industry is that if I am able to fit a Gaussian naive Bayes, then this is the naive Bayes implementation, which is, it's a generic. But the only problem is that the likelihood of the features is assumed to be Gaussian, right? The likelihood of the features is assumed to be Gaussian. This is where the only problem is. If my variables are not normally distributed, or if I am not in a position to normally distribute them, right? Because the moment I do that standard scalar kind of a thing, the scale changes. So at a later stage, if I have to explain the outcome of the model, that will be very difficult because I have to unscale it back, and then only I can explain the outcome. So if I have that kind of a situation that I can scale my data, or I'm in a position to scale my data, then all fine. If I'm not in a position like that, then using naive Bayes, using Gaussian naive Bayes will be a problem. So I'll have to implement something else, right? But as of now, if we only concentrate on Gaussian naive Bayes, we will be able to solve majority of the problems which can be solved using naive Bayes, right? And that is exactly what we are going to do. Let's take a data set, and then we'll try to see what we can do. So the data set that I'm going to take is going to be related to diabetes. Give me 1 minute. I'm not sure whether I've taken this data set earlier or not, but let me just do this. Oh, my God, I'm not able to use this. I think it hanged or what? No. import OS and OS dot list dir. I can see there is a credit card data also. Let me just try to see what is there in this credit card data. So credit card. Okay. I will do this, but I'm just going to import pandas as PD, and then right, and then I'm going to say credit card and the PD read CSV and look into the data first. Credit card head. Right. So this is the credit card data which I have. I believe it will have numerical variables also, and hence obviously I have the defaulted field and so on. Now I don't have the data definition, but I'll still go through the data and see what I can find out of it. So credit card, first thing I'm going to do, I don't need that ID column, right? It is just an identifier. It is not really required. So I'm just going to drop it. I'm going to say x is equal to 1 and in case is equal to 2, right? So I have dropped that field. Now let's look into it. Credit card dot info, right? If I look at the information, I have 30,000 rows and all have the data, right? So it is created quite well. Everyone has the data. But then again, you can clearly understand somebody has already prepared this data for us. I'll try to find out if there is any documentation available for this somehow, uh, right? Uh, which can explain us what this fields really mean, right? Let me just see if I can find that. Uh, so this file is what credit card default, right? Uh, I'm actually searching it on another window, which you may not be able to see. Let me just yeah, search for it and try to find out. Let me see. Hi, Saransh.
Hi, Mohammed. Sorry, I'm late.
No, no, no problem. We just did a quick review and we are looking into uh, how to implement Nightbase. I hope you can see my screen, right? And you
Yeah,
can see
Mohammed.
the Jupyter notebook.
Yep, I can.
So, yes, 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 yes. I got the data. I got the information related to the data. Let me just take this back. Let me come over here. What I'm going to do, let me just do one thing. Insert cell below. And here I'm going to say, yes, this is data overview. Okay, so this is the data overview. This is the data dictionary. So I just got hold of this. This is oh, this is going to be very helpful, but I have to do something. It will take only 1 minute. Friends, give me 1 minute because this is important. Unless and until I know the fields, how will I understand what is going on? So it is an ID field. This is something which I've already dropped. Then the limit balance, amount of given credit in NT dollars. Okay, I'm not sure what is NT meaning here. That's in some kind of a currency. Then gender is already encoded. Seems like it is already label encoded. One for male, two for female. Education is also label encoded. Marriage is also label encoded. Age in years. Okay. Page zero. Repayment status in September 2005 and so on. Then August, July, June, May, April. So this looks like that 2005 kind of a data, right? So it's like the last 6 months of bills, right? The last 6 months of bills, last 6 months of repayment status, and last 6 instances of my previous payments. How much I have actually paid. I hope you got the point, right? So these are the 6 variables, which is what I have already paid. Okay, amount of previous payment, right? This are the 6 values, which is the bill amount, right? And this is the repayment status, right? So, uh, okay. So you will have a look into page 0 and try to see what is going to be the case. But default payment next month, is this there? No, defaulted. This is defaulted, right? So this is actually my target field. Okay, so this is the data definition. Let me just quickly cross check if this is correct. Um, yeah, fine. Okay, so I imported the data. I will have a look into each and every field, no problem. So what I'm going to do, I import matplotlib pyplot pyplot as plt. Even more important than that is to describe the data. Oh, sorry, it will be credit, credit card, right? I just pressed the tab. Why is it not taking? Yeah. So uh, there may be some outliers. There may be, because I can clearly see some outliers on limit balance field. Outliers are really possible in this case. Again, because of too many columns here, right? We are not able to print it, let's say, properly. So what we can do, we can use this print keyword. It is not going to be bad, right? So we can do that. One thing else I wanted to do, something which I wanted to show you, which I don't think I have shown you earlier. So I'm just going to take a reference of a page which I just saw in one of the blogs, and I really liked the way they have done the exploratory data analysis. This is excellent. So I'm just going to do a copy paste here, and I'm going to tell you what this is doing. This is just a library which I found out, which is there in Python, and I'm going to use that to create a profile report. I'm just going to remove their terminology to mine, right? And I'm going to run this. Okay. This will take some time. This actually depends on how big or how small your, let's say, data is. But this technique is really very good. I'll tell you why. When that output.html comes, right, it's going to tell us every detail. Okay, every detail related to each and every feature in the data. Each and every feature. You don't have to worry whether it is a categorical feature, whether it is a numerical feature, doesn't matter.
Bombing, it's an inbuilt function.
Uh, it's not actually. It has come with Anaconda. So when I
Okay.
installed Anaconda distribution, right, it did not come with it also. Sorry, I installed it. I installed it. It's a manually. So in this page only, you will find the command you see here. So I use this pip install command to install it. Right. Once I
So
am
it's a new
done,
library.
right, it's just a new library in the Python area. So from there we can do the profile report kind of thing, which gives that very good output. So this will take some time. Let's wait for it. But when we are done, right, it's going to give us the entire report about the data. So we don't have to spend much time on the data analysis by writing code over here. We can do that, right? But we'll save a lot of time. It's like we are running a software which is going to generate a file. I'm just going to look at that file.
Okay, so it will include all the basic EDA that we do
Uh,
automatically,
yes, you can say only the basic ED. Yes,
like summary and what kind of data we have.
yes, yes.
Okay,
So,
this is nice, really nice.
yes. This is actually something which they have borrowed, I believe, from R, because in R there is, or I believe there will be already such a library. At least in other statistical tools, right? There is already such kind of libraries which is present, like SAS or
Yeah, but
NMI.
for EDA, R is really nice. I mean, there's a
Hmm.
lot of features, lot of things.
Libraries.
Yeah.
Okay. Let's wait for 2 minutes. I believe this will take some time, right? But the point is, we are going to use Gaussian knife base. Let's wait for this to complete. That we have started it. Why to interrupt it? Let me see what it is doing in my command prompt. There is nothing wrong. Is there anything wrong in my task manager? Let me see.
But Bhumik, somehow I find deploy library functions are quite easy on Python than R.
Mm, what do you mean by deploy?
Yeah, the dplyr library.
Uh-huh.
Okay, so that's a little codey on R, but on
Hmm.
Python it's the same thing is quite easy to perform.
That is true. Coding wise, I mean, Python is more closer to being the English language, hence it is very easy to write. But if you
Right,
do the
right,
comparison, right, of the visuals, then I would strongly recommend R has a far better kind of a visual as opposed to
right.
Python, because in Python you have to make some changes to make it look so good, right? But in R, it is by default really very good.
Yeah, Bhumik, right. So purely as a statistical tool, R is really nice.
Yes, really nice. Generate report structure. Okay, let's wait for some. Okay, I'm done. Render HTML. Just connected my charger so that it use some extra power. Done. Okay. So what I'm going to do, I'm going to go back to my folder and I'm going to click on output.html. Right. So once I open this, now look at what it has done. Okay. It already has some tabs here. I'm not going to click on them because these are just the continuation. So when I scroll down, right, those information will come up. First of all, it is talking about the statistics. It says 24 variables. Clearly, I have 23 features and one of them are the targets. I have 35 duplicate rows, right? I have 35 duplicate rows. So there are repetitive rows also. Most probably they may even be because of some oversampling kind of a thing which is already done by the data collector, right? But this is the size of the data. I have 21 numerical fields, two categorical fields, and one Boolean field. It is able to identify that from the data. There are certain warnings which I'm just going to ignore as of now. Now, for each and every variable, okay, for each and every variable, it is going to give me the statistical descriptions here, and then it is going to give me the visual description here. Okay. So, this is what is good about the report. For each and every value, okay, I don't have to do anything else. I just have to. It's taking quite a good amount of time. I don't know why. But for each and every variable, I can clearly look into the data, look into the distributions, right? I can look into what kind of a distribution the data has, where there is any skewness or not, right? I can also see the percentage of the missing data which is there in each and every variable, right? I don't see any missing data there. Won't be, but there may be duplicates because we have already seen in info there are, right? Now here I have this one problem which was showing as the warnings. There are a lot of zeros. Okay, there are a lot of zeros. You see, there are 49.1% of rows where I have zeros, which means pay zero, this variable referring to whatsoever feature it might be, it has 49.1% of data, which is zero. Either that zero is because the data was missing or it is a genuine zero, right? Which means nothing was paid. Pay zero, I believe, is a pay field, right? So nothing was paid in that case. This is the case with almost all of the pay underscore fields, you see. For almost all of the pay underscore fields, this is the case. Then for bill amount also, right? For bill amount also, there are some cases where bill amount is equal to zero. This is also logical. I mean, I'm not saying that this is wrong. Just because I have a credit card, that does not mean a bill will come. If I don't use it, other than the annual charge, which I have to pay once a year, right? Or that is what happens in our country. Maybe that is not the case in some other place. But in our case, in the Indian context, if I say yearly, I just have to pay the subscription charges if there are any. If that is not the case, if I don't use the credit card for 6 months, the bill amount for those 6 months is going to be zero. So it is quite valid that the bill amount can be zero. So this is not really wrong. But I'm not sure about those pay fields. Now, again, in the other pay fields also, there are some kind of, let's say, missing data, right? Distinct or the duplicate values are still there. We will look into duplication, right? This is the final class. Okay, this is the final class. There is good amount of class imbalance. This was supposed to happen because uh, in case of any classification kind of a problem, right? Class imbalance is a very, very common issue. So this is not something that we should really be bothered about. This is where the real picture come into place. You see what it is doing. By default, it is comparing limit balance to limit balance interactions. Now you click on, let's say, limit balance, and you can select any other, let's say, continuous field from here. This page is not really opened yet, so that's the reason why I am not able to view this. Let me close this and let me open this somewhere else. I think it found. Let's just see the task manager. Give me 1 minute. Yeah, this is very slow. Not sure why? Let me just close all the other documents. I don't need them as of now. So let me just close them. Let me close some other applications also. That is going to help. First window. Good. Close this window also. Okay. What is this thing? Hmm, something is wrong. You can still hear me, right? Yeah. I think it is
Yeah,
back now. Good. So let me just reopen that file. No, I'm not going to do it like that. I'm not going to open it from Jupyter Notebook. I'm going to open it from somewhere else. So documents, and in our folder, there's it's a big file, a really big file. It's taking a lot of time to render. You see, that is where the issue is. But the point is clear, right? This is what the outcome is, and really very good information is already provided, right? And then there are other things also which we can find. We can find the interactions, we can find the correlations, the missing values, the sample, the duplicate rows, and so on. So I don't know why my laptop is so slow as of now. I'm not able to run this. Okay, so let me share this file with all of you. You should be able to do that. So let me see if I can share it right now. No, I don't think I can share it right now, which is okay. I'm going to share it after the class is over, right? So in the LMS, I can share it, right? But this is a very, very good way. So this is a really nice way, most probably because of some limitations on my laptop, it is not working, right? But this is a very nice way to understand how the features are correlated with each other and so on, right? But even if we have done that, let me just find the correlation matrix. And what I'm going to do is that I'm going to look at the defaulted column. So defaulted column, yes, there is one good positive correlationship. Okay, positive correlationship is with pay zero. Okay, if that amount is paid, right, then there is good correlation of whether a customer will default or not. To do it in this way, big size is equal to 14 by 11. PL SNS dot bitmap. Pass this. I'm not going to annotate PLT dot show. Okay. Oh, of course, yes. So import keyboard as SNS. Let me see. Yeah. So we do have some very good Yeah, we do have some multicollinearity problems. You see, page 0 to page 6. Oh, obviously, this will be interrelated only. Why is it? No, but okay. K2 is correlated with K0. Okay. Okay. So all the next page are correlated with the previous page. You see, this is what they issue. K3 is highly positively correlated with K2 and so on. Right? This is logical, but do we really need these variables? Let them be there. We'll try to minimize the multicollinearity problem by scaling the data. Although the data is already no, it is not already scaled, right? No, it's not already scaled. But when it comes to defaulted field, there's this limit balance which has a good negative correlation. P0 has a good positive correlation. Uh, pay amount 1 until pay amount 6 has a good amount of negative correlation that you can see over here. This field has a good positive correlation, which is P0. Limit balance has a negative correlation. Sex has somewhat negative correlation. So does education also, but this is coming closer to the this area, right? It is coming closer to that area. This is higher. This is like a positive correlation. Limit balance has a negative correlation. All of these have a negative, right? So keeping that in mind, let's see what we can do. So first thing I would like to do from sklearn dot preprocessing import standard scalar. This is the first thing I would like to do. And what I'm going to do, I'm going to create my X and Y credit card dot drop. I'm going to select what defaulted, right? Defaulted. And then I'm going to say axis is equal to 1 and y is equal to credit card, sorry, card in small, defaulted, right? So now I'll create a new variable called x scaled, which is going to be st dot uh, dot fit transform x, right? Now I have the scaled data. Now what I can do, I can use this data to do the modeling from sklearn dot model selection import 10 test it. Now x train x test y train, sorry, y test is equal to train test split x scaled y test size is equal to 0.3 and random state we set is 1. Now I have the data in training and testing. Now what I'm going to do from sklearn.naive base import Gaussian naive base. I'm just going to implement it first, okay? NB is equal to Gaussian naive base. And then I'm going to tune the model. Let's see if it is able to work because outlier is a problem I have solved. Okay, multicollinearity is not really a problem that I've solved. Okay, but let's see how Gaussian naive base is going to behave. Okay, so what I'm going to do nb dot fit x train y train, right? Now y pred nb is equal to y pred, just y pred. Okay? nb dot predict x test. Okay. Now from sklearn dot metrics import classification report confusion matrix. So that's all I'm going to do because this is an imbalanced kind of a data. I'm not going to look into uh, the accuracy score. Okay, so I'm going to look into something else, classification report, and then I'm going to look into y pred y test. Okay, it's not bad, but it's not good also. And overall, it gave a very good, I mean, performance. If you look at the F1 scores, they are not bad, but they're also not very good. Uh, the problem is not with the first one. The problem is with the second one. If you have understood what is the meaning of recall, you clearly know that in such cases, okay, where one refers to something bad like having cancer or being a transaction which is, let's say, fraudulent. So this is something wrong, which is something we want to stop, right? In that case, recall should be higher. Our model is actually doing something the opposite way, right? For zero, right? For zero, it is working quite well. Let's try and understand what 0 and 1 means. So let's go back to the data definition. Okay, defaulted payment. 1 means yes, 0 means no. Right? So 1 means a customer who has defaulted in the credit card payment. So this is the wrong thing or something that we are trying to predict, something which we are interested in. Now, like if a patient has cancer or not. So in that case, recall should be higher, precision should be lower as compared to that value, but that is not the case. So our model is really not that good, right? Our model is really not that good, most probably because we may have some kind of a multicollinearity problem in our data, which we don't know. We have to see, right? But let's look into something else first, then we will look into some other data, right? So let's say I'm going to look into Gaussian naive Bayes, and then I'm going to try and find out what I can tune. But this is where the biggest problem is. In Gaussian naive Bayes, I have no hyperparameter that I can tune, right? I cannot give priors value. This is prior probabilities of the classes, right? This is something which I should not give because this is step number one, right? Prior probabilities is what we discussed as step number one. When it is doing the calculations, it has to calculate the priors. If I give the priors, then how will it work? It has to figure it out, right? So P of class one and P of class two, step three, I'm sorry, step one, two, and three, right? Or step one and three in this case. This is something which the algorithm has to figure out. I cannot tell him. If I tell him what is the probability, and if my calculations are wrong, then there will be issue, right? So there is really nothing for me to tune. So that is the biggest problem when it comes to naive Bayes. Naive Bayes is basis, or the main issue with naive Bayes is that we seldom find a place where you can tune it, right? We seldom find a place where you can tune it. You cannot tune it. So there is nothing that you can do to tune it, right? There is a hyperparameter tuning which you can do, right? That is the kind of advantage or the disadvantages which we have. But let's, I've already give me 1 minute. I've already noted it down in a notepad. Let me just copy paste it over here. Okay. So I'm just going to write it here first. Then we're going to try some other algorithms also. Let's try to do some kind of a comparison. So these are the advantages and the disadvantages. Now, naive Bayes extremely fast. While because in training, what I'm doing is that basis the implementation which sklearn might change in the future also. You may at max be calculating the priors. Other than that, there is nothing which is calculated, right? They do not have to learn or create any separate class, right? They just have to learn the pattern. Then the calculations are really easy because it is direct probabilistic kind of a prediction, right? It is a direct probabilistic kind of a prediction. For example, if you look at this, you did nb dot predict here, right? So if I just insert a cell below and I say nb dot predict and I do a tab, it is also going to give me a proba. Okay. So if I use the test value, these are the approximated probabilities which it has already calculated. For each and every set of data, okay, this is the predict approximated. Okay, this is not the actual one, because if it is the actual one, it should sum up to 100, right? It should not be given in e minus 0, 1 and e minus 0, 1 kind of a scale. It is just an approximated kind of a value, which according to the internal algorithm or the implementation which it is using, it is doing, right? But you can clearly see that the first outcome, it has bigger value, okay, for the first class as opposed to the second class. And that is the reason why, if you look at this output also, let's say, if you look at this nb dot predict x test, you'll be able to see the first outcome has been 0. Why? Because it has taken a vote, right? Out of these two probabilities, obviously the probability of that record belonging to class 0 is higher than it belonging to class 1. Hence, it has declared it is going to belong to class 0. But that is not the case for the second record. You see, for the second record, probability value it has estimated is closer to, let's say, uh, 4.2 something according to its own scale and the kind of math it is doing. But the probability of that record falling into the other class is 9.57. So the value is higher. That's why the outcome is going to be 1. So this is a very good thing to know, because if I understand how it is calculating it, I can do the reverse engineering and try to find out the probabilities also. So if somebody tells me, okay, if somebody tells me to write an application where I'm going to, in the front end, I'm going to enter, let's say, my IELTS scores, my GRE scores, how much I scored into class 10 and class 12 and so on. I can try to create an application like this into Python using libraries like Django or Flask and so on. And then when, let's say, Rohi enters his details, right? The moment he clicks on to submit, I'm going to not only give him a prediction whether he's going to get selected in the US Ivy schools or not, I'm also going to give him a prediction percentage, right? I'm going to say that it's the flash which is going to appear, or the pop-up which is going to come up is going to say it's a 79% chance that you will be selected in the Ivy school, right? So that is one of the most advantageous thing related to naive Bayes, because it gives a direct probabilistic kind of a prediction, which can be reverse engineered to find out what is the exact chances of something happening, right? Given a query point, right? It's quite easy, and it does not have any parameters to tune. So because it does not have any parameters to tune, this is a problem, right? This is, I will consider this as a problem. Yeah, I will actually consider this as a problem. I will write it at both the places. I'll actually write it in the disadvantage also. But in the disadvantage, there is one more, which is algorithm assumes that the features are independent, which is not always the scenario, right? This is where your skills will come to get rid of those things or those variables which are not really correlated with each other. So we have to use techniques like RFE or VIF and so on. But in this case, can we use RFE is the question. You see, there is no, um, uh, you can say, in this kind of a probabilistic kind of a model, there is an attribute which is giving you the coefficients, right? So if it is not giving you the coefficients, RFE will not work. RFE works in cases, okay, recursive feature elimination works in those cases where you have the coefficients in place. Okay, let's try to see if that really works. sklearn RFE. Okay, let's see if it really works. Feature selection, inside feature selection we have RFE. Okay, so I'm just going to insert cell above, and then I'm going to do some new cells. So from sklearn dot feature selection import RFE. Okay, the recursive feature elimination. RFE is equal to this plus RFE. Now I have to give the values here, right? So I have to give, let's say, um, my classifier, which is NB, and N features to select. Let's say I would like to select the top 5, right? Now I'm going to do RFE dot fit, and I'm going to say explain whiten, right? The reason why it fails is because it has clearly told us why it is failing, right? It has clearly told us why it is failing. The classify does not expose coefficients or feature importance, right? We could clearly see that if it would have done that, it would have been there in the attributes area, right? But it is not there. Some others are doing it. Random forest does that, right? In case of, let's say, linear regression, any model which is getting fitted linearly, let's say logistic regression, in that case you will get the feature importances, you will get the coefficients, right? Those beta 0, beta 1, the kind of things. If that is not there, RFE is just a wrapper. It is running on top of the model using the functionalities which is provided by the model, and it is trying to calculate which is a good feature, which is a bad feature. That backbone itself is not there, hence a thing you can do. So in this case, VIF is your only option to look into multicollinearity. Okay, look into multicollinearity. VIF is the only option. I would strongly recommend both of you to give it a try. Try how to reduce the number of features using VIF, right? See if that really works or not. Okay. But there is one more problem also, which is related to zero frequency. This is a very typical kind of a problem. Sometimes it comes. What it means that if the category of any categorical variable in the training data. Okay. So in the training data, it can be a target, it can be a feature also, but uh, it can happen. I mean, it can happen for both. I mean, this problem can happen for both a feature variable or a target variable. But if the category of any categorical variable is not seen in the training data, even once, by some chance, okay, by some chance, it is not there even once in the training. So the example is not there. Maybe your sampling is wrong, right? Maybe the way you have collected those 3,000 or the 30,000 rows, right? That itself is wrong. So you did not collect any observations for a particular class, which means the model assigns a zero probability to the category, and then a prediction cannot be made. You have to be very careful about how you are sampling the data, how you are collecting it, right? Any questions here, friends? So that's all I had to show you on this. Any questions? Any doubts?
No questions from my side.
Okay.
No
Uh,
questions from. Understood.
okay, friends. Then let's close the session. I'll share the files with you. Have a look. I'll also share that output.html file also. It is running a bit slowly on my laptop. Not sure why. Right, but please try to run that on your laptops also. See if it works. Give it some time, and it is going to give you tremendously valuable information. It's really very good that Pandas has involved some kind of a profiler kind of a tool, which is really useful. It will save a lot of coding time. I'm not going to say it's going to save a lot of analysis time. Actually, it's going to increase the analysis time because it is giving you more information than you could have coded within a day. Right. So that's really good. It is giving a lot of info, which is really, really nice. Okay, have a look into
Yeah,
that,
Bhumik,
friends.
and you
Ah,
can even share that with someone across, across
yes, exactly. That is the point.
maybe
Yeah,
in a simple manner. They don't have to
right.
run the code for that.
True, true, true. I mean, if let's say there is any project on which we three are working, I
Right,
don't necessarily expect you both to run a piece of code, then only you will be getting an output. If I've already done that profiler part, I can simply share the file,
right, right.
right? Okay, friends. With that note, let's stop the session. As of now, we are going to continue from tomorrow. Thank you
Thanks,
so much,
Bhumik.
friends.
Good night.
Thanks, Mamik. Good night.
Thank you. Good night. Thank you.